Following on from the previous video, we are still trying to work out the area of this thing here. As it turns out, the area of this thing, let's call it capital Q. Q turns out to be the square root of the volume. So another way of stating it is that Q squared equals V. If we can verify this, then we will know that this here is true. Okay, so our job here is to verify this. Our job here is to verify this. So there are two ways of working out the volume of this 3D solid here. One way would be us summing up all the shells, which we've seen many times, and another way of doing it would be us summing up all the slices along here. So it's really us summing up all the slices along here. So the way we verify this here, the way we would verify this is by working out the volume of this 3D solid, but we would do it in slices like this rather than in shells. So the way we would verify this is by summing up all these slices. Okay, so if you look at this solid here, if you look straight down on it, it will so a bird's eye view of this 3D solid will look like this. Okay, so this is the highest point, and then it gets lower, 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 and then all the way to infinity. So looking at the 3D solid here, if you look straight down on it, it will look like this. It will look like this. Okay, and then so this is your y-axis. So this here is your y-axis. Okay, now if you so this is your 3D solid. If you imagine getting a knife and then cutting it along here, you would get a cross-sectional area looking like this. So if you get a knife and then cut it along the y-axis, that's really you doing this. So looking straight down on it, it's you getting your knife and cutting it along here. And then when you look at it from the side, it will give you this thing here. Okay, now imagine so you start out with this. Gear your mind into thinking that you're revolving this 360 along the y-axis. It will give you this solid here. Now, if you get your knife and then cut along the x-axis, that would be you doing this. If you get your knife, cut it along the x-axis, and then look at it from the side, it will still give you this kind of a shape. It will still give you this exact same shape. But if you cut it along here, so hang on. If you this is your 3D solid here. If you cut it along the y-axis, it will give you this shape here. Okay, if you cut it along the x-axis, it will give you the exact same shape. It will give you the exact same shape here. If you cut it at an angle here, let's say at 45 here, it will still give you the exact same shape. It will still give you the exact same shape. If you cut it at, let's say at 17 degrees here, it will still give you the exact same shape. It will still give you the exact same shape. But if you cut it at, let's say from here to here, where x equals b, if you cut it along here, if you cut it along here, so hang on, if you cut it along here, so it's parallel to the y-axis. Okay, so if you cut it along here at x equals b, here. Remember, if you cut it parallel to the y-axis, so looking down on it, it will look something like this at x equals b. Then it would give you this shape here, but smaller. If you cut it along the y-axis here, it will give you this big shape here. It will give you this big shape here. But if you cut it along here, it will give you the exact same shape, but slightly smaller. But my next question is, how do we know that if you cut it along here, it will still give you the exact same shape but smaller? So for example, if you imagine this as being a 3D solid, if you cut it along the y-axis, of course you're going to get shape here. If you cut it along the x-axis, then of course it's going to be the exact same thing. But if you cut it along here, if you cut it along here, let's say from here to here, how do we know that this will still give us this kind of a shape but smaller? The way you can, well, you really got to pause the video and think for yourself. Try and reason with yourself. If you cut it along here, as it turns out, it will still give you the exact same shape but smaller. And the way you can see that, if you cut it along here, it will still give you that. It will still give you this shape but smaller. And the way you can see it or convince yourself is by looking at it like this. If you look at this thing here, if you look at let's look at this thing here. The further you go away from the center, the shorter the height will get smaller and smaller. So if you go a short distance away from the center, the height is quite big. If you move further away from the center, the height gets smaller. If you go even further away from the center, the height gets smaller and smaller. So if you just know that the further you move away from the center, the height gets smaller and smaller. So if you cut it along here, hang on. If you cut it along here, hang on. So remember, this line has to be parallel to the y. So if you cut it along here, so looking down on it, it will look like this. If you cut it along here, okay, notice that this distance here, from away from the center, is shorter than let's say this distance here. So of course, looking down on it, this is going to be really high. And then so don't forget the if you like, the adjacent here is nearer to the center than if you like, well, hang on, let's start again. If you cut it along here, this distance here is shorter than this distance here. So this distance here is really the height. This height here. Okay, and then if you move slightly out here, then this point here will. Don't forget if you cut it along here, that will be us looking at along here like this, and then this bit here corresponds to this. Well, the height at this point here corresponds to this bit here. My point here is that if you cut it along here, this distance here is shorter than this distance here, and then as you move out here, the height is further away from the center, so the height will be smaller. So if you go out even further, then the height will get smaller and smaller. So this bit here, can you see that from here to here, it is shorter than from here to here. So the height here, well, if you cut it along here, this distance here is shorter than this distance here. That's why the height here is bigger than the height over here. The point that I'm trying to make is that the way you can convince yourself is by, I hope I can convince you, this distance here is shorter than this distance here. And remember, the further you go out, the height decreases. So as you move along here, you can see the distance is further away from the center, so it decreases, so the height decreases. Well, I hope you can see that. I will continue in the next video.